Hello, good morning, everybody. Uh, Today I am going to talk about modeling and designing the RC snubber circuit for buck converter and testing its effectiveness. My name is Ali Al-Gaddafi and I am from Libya. I will talk today how to design the RC snubber circuit and how to implement with the buck converter in order to protect the switch from over voltage and protect the other electrical component. I am originally from Libya and I study at the University of Demonfort in United Kingdom. Let us move now for introduction of my presentation today. The presentation outline of my presentation will include following. Firstly, we'll introduce the topic of my project and I will highlight the aim and objective of my paper and will describe the system configuration, that is including the analyzing transit switching and how to develop buck converter, and also we will develop the RC snubber circuit. We will present as well the simulation and experimental work for how to design RC snubber circuit with mathematical equation, that is help us to design the RC snubber circuit which is not part from power electronic circuit, as you will see in my slide. Let's move now. Introduction. The semiconductor devices are the core of all the power electronic devices, which is required more protection, and when I protect the switching power converter, that's including switching whether transistor or MOSFET or ABGT, it should guarantee the more stable system, and we should guarantee that is our system is working in safe level. That's required. So in this paper we will present how to design RC snubber circuit to reduce the stress in the switch. We will implement in experimentally and by modeling as well, as you will see in my next slide. The main goal of my paper, how to design the RC snubber circuit, how to obtain the optimal value for RC snubber circuit. Firstly, what we should do in my paper here, we will modeling the DC-DC buck converter in PSpice, and I will test the waveform of the current on the switch, and then we will design RC snubber circuit according to mathematical equation, which will be validated in experimental later when I try to test it. So we will find how to find the optimal value to reduce the losses in buck converter, which will make the system suitable and work for long. As you can see, how is it the waveform for the voltage and the current in normal switch. From a previous study, as you see here in this figure, you will see that is the voltage, the level of the voltage high when the current, for example, if the current 0, the current will raises until the level of the current come high, then the voltage drop. You will see the triangular between the voltage and the current. This is considered as losses. When you try to switch off the MOSFET, you will find the voltage raises gradually until the voltages come high, then the current will drop. If this losses, we don't need this gap. In this paper, I have designed the buck converter, and the buck converter which I have designed in the lab. Firstly, I've developed it in BSpice software, which give more accurate result, and then before we design it in the lab, I've selected the parameters of capacitor and inductor for the buck converter to be 1 microfarad in order to design the buck converter, in order to design the fast response of the buck converter, which will be used in BV array emulator. So at this point, I've designed the buck converter and included the RC circuit with it. When we modeling the buck converter in the lab, is difficult to design it in the lab. But when I want to implement the RC snubber circuit, we should test it in BSpice. Why? We've got some mathematical equation to find the resistor, and then we can use the sweep parameters to find the optimal value for the capacitor, that is give low losses and reduce the impact of the losses and overshoot in the switch as well. From this model, I will show you how to compare between the circuit which has RC snubber circuit and the circuit for buck converter without a snubber circuit. I've compared between the current and the switching, as you will see in the graph here. However, in the lab, if you have a good tools, a good oscilloscope, and a good equipment, you can find the ringing and the oscillated frequency for the switching, and from this point you can determine how much the frequency you need to remove it, and you will be able to implement the two mathematical equation and find the optimal value for the resistor and the capacitor for a snubber circuit, which will be easier than the modeling. The modeling you can use sweep parameters, but in the experimental it's better and give. Let's see how to calculate the optimal value for a snubber circuit, resistor and capacitor. Firstly, from the experiment we find that the frequency ringing and for the snubber circuit, and we can calculate it by using oscilloscope. From that we know the value for inductor and capacitor. We can find the resistor, which depend on the damping factor. As we know, the damping factor, it has 4 cases, so the damping factor is necessary, and I present it in the book, which will be in Amazon. And after we calculated the resistor, we can calculate the capacitor by using those. You can see here in this experimental setup how we configure the buck converter and how to supply it with high voltage 300 volt DC, and also we using the power analyzer to measure the output voltage, and we've got the variable resistor. If you see it in the figure here, that is, we can change it to test the BV array emulator, because this is experiment is part from the other work which design BV array emulator. But the first step here, we've designed the buck converter and we implemented the snubber circuit. The snubber circuit, if you see it here in the MOSFET, it is connected by two wires which connected on the MOSFET. This part, it is connected to protect the switching, and we have measured the impact of the current and voltage on the MOSFET during using RC snubber circuit and without a snubber circuit. Firstly, we need to guarantee the buck converters work correctly and safe operation. As you in this slide, I will show you how to measure the current and the voltage over the switch when RC snubber circuit is not used. If you can notice here, and you will see in this voltage, it is twice of the level of the voltage. I am here using 30 volt only. The 30 volt is can protect the level of the voltage is low, so the MOSFET will not damage. But imagine yourself using a 300 volt, how much you will get voltage a spike on the MOSFET. This high voltage will definitely damage the MOSFET. The high level for MOSFET, it's around 100 to 1200 volt, but if you make it 100, it will be more spike and ringing as well on the MOSFET. This definitely when the MOSFET is work for many times, it will damage. So this is why I've designed the snubber circuit. Please notice here the spike voltage, because the next slide will show you how the voltage reduce. You can notice here when we using the RC snubber circuit how the ringing firstly is reduced. The spike voltage is reduced, and also the spike current. So with this operation, we guarantee that is the buck converter will work safe, and we can implement until 300 volt. This is the barrier of design BV array emulator. So this is the work is part from other work. So firstly, I've designed the buck converter, I've designed a snubber circuit, and after that we implement the control circuit for buck converter. Not only we satisfied by measuring the voltage and current on the MOSFET, but also we need to focus on the whole system together. So what I did, I measure the output voltage and current, and I look for the ripple current and voltage, ripple voltage output, but there are no ripple and the result is acceptable. Then after this procedure and this design, we can implement the control, and we can design the BV array emulator, which we can test the BV inverter. This is what I have done. Also, I've tested the pulse width modulation on the MOSFET and from the generator, and on the MOSFET it noted that there some tail time. We come for conclusion of my presentation. I found that Isman engineering ignore the impact or effect of RC snubber circuit in switching power electronic. The RC snubber circuit, which we've designed here, can reduce the noise in MOSFET, and also we noted that is the RC snubber circuit, we can ignore it in MOSFET, but in IGBT it is not possible to ignore the snubber circuit, and the stress should be reduced. And we have established how to estimate the ringing frequency in order to find the optimal value for the capacitor and resistor. Thank you very much for listening for my presentation, and you've got my email. My name is Ali Al Gaddafi, and my email it is alisirte@yahoo.com. I will be happy if you have any question to send me email, and I will reply you since I received your email. I'm sure this is my presentation will be useful for technical people who using design the buck converter or design the snapper circuit for any DC-DC converter, which is very useful, and also it is very useful for IGBT, MOSFET, thyristor, whatever. Thank you very much again. Thank you very much. This is my email. I leave it for you to record my email and send me your comment and question. I will be happy to receive your email. Thank you.